Okay, so for question number 2, we have a particle of mass 0.8 kilograms projected with a speed of 12 meters per second up a line of greatest slope. And the slope is rough, inclined at 10 degrees to the horizontal. The coefficient of friction between the particle and the plane is given as 0.4. We've been asked to find the acceleration of the particle. What we want to do is, I suggest you draw a diagram, because a diagram helps you visualize the forces acting on the particle and helps you decide on how to put the equations that pertain to its motion. So if we have a slope here inclined at 10 degrees to the horizontal, mark the 10 degrees right here, and let's say the particle is sitting at this point. The weight of the particle acts vertically downwards, but we don't show that because we're not interested in motion in the vertical plane. We are interested in motion along the horizontal plane. But we know that the weight of the particle acting vertically downward is resolved to give us two components. There is the component of the weight that is parallel to the slope, which will be given by mg sine theta. And there is the component of the weight perpendicular to the slope that is always given by mg cosine 10. Well, there is the reaction force because of contact between the particle and the plane, which we will indicate in this direction as R. Now, because the plane is rough and the particle is projected upwards, that implies we will also have a frictional force opposing the motion of the particle up the slope. So we include that force down the slope in the opposite direction to motion and call it F. Now, a few things that we need to know since we have the diagram. We know that the particle is not going into the plane and it's not jumping off the plane. So that means that the reaction force must be equal to mg cosine 10. Well, I did put theta here and I put 10. That was just a misnomer because I know that the angle is 10 degrees. So mg cosine 10 is the value. And if you go ahead and plug in the values of that, that will give you 0.8 times 10 multiplied by cosine of 10 degrees. Now, as far as the parallel component of the motion is concerned, there is no force in the vertical direction, in the forward direction. And so because there is no force in the forward direction, if we wanted to write Newton's second law for this particle, we will have, well, it says that this resultant force is supposed to be equal to the mass times the acceleration. That implies that zero force, because the particle is just projected, it's not being pulled up the slope. So 0, which is the forward force, minus, now we have two forces in the backward direction. So I will sum those two backward forces. While summing them, I'll put in the values. So this will be 0.8 times 10 sine of 10 degrees added to, now I'm using added here because the two forces add up, but there is a minus sign here indicating that they're in the opposite direction. So this added to our value of the friction, which is always given by mu r. So mu in this case is 0.4 multiplied by, we just found that the value of r is this. So 0.8 times 10 cosine of 10 degrees. So forward force minus backward force is the resultant force, should be equal to the mass times the acceleration. So that gives me 0.8 a, because the 0.8 kilogram particle is the one accelerating. Now, if I open the brackets and put in the values of this, I will get 0 minus the first value we've computed will give you 1.389. And then the minus sign operates on this, which computed gives me 3.151 as being equal to 0.8 a. Now if I do the sum of these numbers, I will get minus 4.54 as the overall force being equal to 0.8 a, of which if I make a the subject, I will get minus 4.54 divided by 0.8, and that gives me a value of 5.6 meters per second squared. It's a negative value. Actually, to be fair, it's minus 5.68 meters per second squared. So that will be the acceleration of the particle up the slope. That means the particle is decelerating. Although the particle goes up the slope, it actually slows down because of this value. In part 2 of the question, we are asked to find the distance the particle moves up the plane before coming to rest. So if we go back to our diagram, we are thinking of the fact that this particle, which is decelerating, will come to a stop at some point here and would have covered a certain distance along the slope to get to that point. Any particle that stops has a final velocity of 0. So if we take what we know from the first part of the question, we know that the acceleration is minus 5.68 meters per second squared. We know that the final velocity is going to be 0. We know that the initial velocity with which the particle was launched, as given in the question, was 12 meters per second. So at this point, it has 12 meters per second, but it will stop with 0 meters per second. So we have the value of u as 12 meters per second. Now, we are interested in S. And if we look among the Suvat equations, the most appropriate one to use is going to be v squared equals u squared plus 2as, because it has nothing to do with time and no time has been given here. If we decide to put in those numbers, we will get 0 squared should be equal to 12 squared plus 2 times minus 5.68 s. If we rearrange, 0 squared is of course 0, so we'll have minus of 12 squared being equal to 2 into minus 5.68 s. A good rearrangement of this will give you s equals minus 144. Take note the minus sign is outside, so the 144 remains what it's supposed to be, divided by 2 into minus 5.68. What that gives you is a value of 12.7 meters. So that means this particle, launched with its speed of 12 meters per second, is able to go up 12.7 meters before stopping. And that would be the solution to the second part of the question.